Hello, everyone. You should be entering the webinar now. We'll just give people a few moments. Thank you for joining on time from wherever you are in the world. I'm Henry Gordon Smith. I'm the founder and CEO of Agritecture. And for those of you who don't know about us, we really want to help society adapt to climate change through smarter agriculture. And that includes controlled environment agriculture, greenhouses, vertical farms, different methods of production. And as part of that mission, we work with incredible companies to share technologies and data and knowledge. We do that also through our blog, and we do consulting services as well. And it's really great to be here because this is one of these webinars where we want to really share knowledge and gather insights together. And I'm really proud to be joined again by Abhay Thosar from Sollum Technologies. Abhay, how are you doing?
I'm good, Henry. I'm good. Thanks for the introduction. So yeah, now it's been, as you rightly said, it's been last couple of days. It's been really busy with for me, especially with the Canadian Greenhouse Conference
Uh-huh.
right here in Niagara Falls, Ontario.
Yeah.
We had a booth there, of course. So yeah, it was really nice to be there, meet a lot of different growers from the Ontario region as well as all across the Canada and even a few from the US, to be honest. So yeah, it was a really good conference that we had there.
It's a very good conference. I agree with you. I'm glad that you participated. Canada, massive market, North America's largest greenhouse market, right? So the critical location. So being there in Niagara Falls and, just a little bit out of there is this density of greenhouses similar to what we see where I am today, which is in the Netherlands,
Correct.
which is another large cluster of greenhouses. So what did you learn at that event? I just want to get something fresh, since we're here learning about this. Like, what are some observations you had from that event, maybe about that industry or?
Yeah, so one of the things that, because I've been attending this conference for last almost 15 years, I would say, if not
Yeah, I've
more.
been there like 3 times. It's a good one. I like it.
Yeah, so I've seen a lot of change happening through all these years, and especially in the last 2 to 3 years, what I've been seeing is, of course, we have been seeing the change from HPS to LED. I'll be honest, I'll talk about the lighting industry because that's where
That's your
I've
thing.
been.
That's your
Yeah,
thing. You're the lighting guy. So
well, not just that, but also because I was a grower and going from, being a grower into the lighting, now I can see how things are changing, with the mentality of the growers, the mentality of the owners. So moving from HPS to LED, it was more static LED, all about pricing, how much does the LED cost, yada, yada. That was basically everyone, oh, it's too expensive, HPS, I lose the heat, like the same thing. This year, I saw it was a big shift, I would say, where people were saying, well, let's not talk price. Let me see what value you can bring to the table. And
mm,
that was really a big thing that I learned from, at least from this last 2 days, was people talking about, okay, I get it. You have a dynamic light, but what value does it bring? And how does it translate into whether it is additional production, additional income? How does that translate? Let's talk about that. So that's a big mind shift, I would say.
well, that's a healthy bit of skepticism, right? To really look at the science and understand the economics of how dynamic lighting might work. So we'll get into that and as a little bit on your experience as well. I'm in Amsterdam right now. I was at the Vertical Farming Congress, and vertical farming
Mhm.
has gone through a major downturn. So it was very interesting to hear from several companies that are still operational, some that are growing. 80 Acres was there, various, Growy was there from Amsterdam. And it was really interesting to see because I've been in this industry for about 12 years and it's just really changed a lot. Huge discussions on profitability as well there, right? The main topic was, is it
Yeah.
profitable? Can you get the long-term contracts for the markets? Those were the two things that I think were really emphasized. So it's great to see a more honest, straightforward, data-driven discussion in our industry overall, no matter which continent it's on. I think that
Yeah.
we
Yeah.
continue those discussions. And that's what we're doing here today, everyone. If you're just joining in, I'm Henry Gordon Smith, founder and CEO of Agritecture. I'm joined by Abhay Thosar, who is leading plant science at Sollum Technologies and really is going to talk to us about that related to leafy greens and lighting. But we're here doing an open webinar, a direct Q&A webinar with you. So this is how it's going to work. Basically, we can talk about anything really within the realm of controlled environment agriculture. I'm more of an expert on some of the business sides of things. Abhay obviously is very knowledgeable in the science and lighting and also has been a grower. But let's start off with an introduction from you, Abhay, and then we'll start to get some questions from the audience. Audience members, we're willing to take live questions with camera on. So if you're open to that, please let us know. Just put it in the chat and say, what's my question? And say, yeah, I'm cool with that, because we'd like to have a conversation with you to make it more dynamic. And we have some previous questions that were submitted, which we're going to get into today. But first, Abhay, could you maybe tell us a little bit more about yourself? I've got a little bit of slide, just background on you here to share with the audience about your experience, but tell us a little bit more about what your background really is beyond this.
Sure. Yeah. So to begin with, as you probably a lot of people know about my background is I'm a plant physiologist to begin with. And what that means is being a plant physiologist, I like to focus on a lot of different factors that would impact the growth, productivity, the biological processes within the crop itself. And that light is something that would drive those processes. And that's why I like my job, what I'm doing for all these years. That's exactly for that reason. So yeah, being a plant physiologist, I like to look at the complete solution of how we can excel the plant performance. So that being said, I worked for almost 12 years after my PhD. I worked in commercial greenhouses just to get a handle on different crops, how it is done in commercial greenhouses. What are the actual challenges that the growers can face, and also come up with some practical decision making, because yeah, science is one thing, but the practical applicability is something different. And as a grower, you learn that how to apply the science in a practical manner. And that was important for me to learn. And then from there on, for the last 12 years, I've been focusing more on application of horticulture LED solutions in various crops. It could be high wire crops, leafy greens, strawberries, lettuce, herbs, even cannabis, ornamentals, a lot of different crops that I have focused on. And I had my journey go through starting with the static LED solutions, because those were the most commercially viable solutions back in say 2012, in especially in North America. So we started with that, and then for the last couple of years now, I've been also focusing more on how can dynamic solutions, bring to the table. What impact does it have on the crop? So that's where my focus has been. As you can see, it is more understanding the needs of the grower, the objectives, okay, based on wherever they are located, what the crop is, and try to give them the best possible practical solution, not a scientific research paper, drop in, yeah, this was the research done. Sure, that's great. But that's the way I like to think as a grower and provide a practical solution to the grower, if that makes sense.
Yeah, it totally makes sense. I mean, what a great balance, right? We want the science side of it, and we want the operational side of it as well. And I think that's what I always like about having these conversations with you, is that you can talk about both of those a little bit together.
Yeah.
So do you want to just maybe just give us a little bit? We're trying to get into the Q&A soon enough, and everybody can ask questions, but what is a dynamic light, just for the basics? Because we never know who's on this call, how much they know about this topic yet.
Yeah, no, absolutely. No, that's a good one to start with, because a lot of people, they just think that dimming the lights, it would be considered dynamic. Yeah, in a way, it's partially, I would say, but it is not the advanced dynamic solution that Sollum provides with the four channel, tunability. And when I say four channel, it would be the red wavelength, the blue, the green wavelength, or white, however you want to call it, and the far red wavelength. All four channels can be fine-tuned individually, anywhere from 0 to 100%, as much as you want based on the requirement of the crop. So that's one of the things that Sollum brings to the table, is the hardware with the four-channel tunability spectrum, or a fixture. But then also important is the two other pillars that Sollum brings in, which I don't think so anyone in the industry has. One is the Sun as a Service platform, which really brings in the flexibility, the adaptability for the growers, which they can do just with the click of the mouse. Like literally before our call, I was talking to a grower and we want to make some changes to the zones because they were growing a certain for the propagation phase and then the finishing phase. I just did it with the click of my mouse, and the grower was also looking at it on his screen, and he was like, "Well, so I don't need to change any wiring, nothing." I'm like, "No, it's already done. You're good to go." So that easy solution, and however very effective. And then the very important pillar that Sollum has, which we provide complementary to our customers, is the agronomic services. That's where my role comes into play, where I would work directly with the growers, explain them the science and how it translates practicality into the application in the greenhouse. So I think that's where Sollum has carved a niche for itself for the last 10 years. And now we are really getting into where people are understanding that this is a commercially viable product. Yes, we can apply it in the greenhouse.
Thanks so much for that overview on dynamic lighting. And, I think in regards to that agronomy specialization, which Sollum has, and that service connected to the sun as a service and the agronomy background behind that, which, you're part of, I think that's what this is about. We want to ask questions. So we got some questions submitted. I mean, should we go look at some of them?
Yeah, absolutely. That's why we are here for. So yeah, even I would like to tell the audience, don't be shy. Please, ask questions. Yeah, I would try my best to answer them. I wouldn't promise that absolutely I know everything. No, that's not true. I learn every single day. So if I don't know the answer, I'll make sure that I'll get the answer for you.
Okay, sounds good. So first question, how do you adapt lighting strategies for different varieties? So it could be basil, lettuce, or kale. So obviously for many of these questions, by the way, guys, we have to create a context to at least try to answer it, because there's some assumptions that would need to be made. But yeah, in the context of a greenhouse, I think is what we can assume, for example.
Yeah, so that's a really good question in terms of the lighting strategies for different crops. So as we know, each crop is different. It's not like the lettuce is different than kale, kale is different than basil. The requirements are different. And depending on how the crop is performing in the greenhouse, so there has to be a baseline. So that's where I usually start. When I'm working with the growers, you have to have a baseline. So whatever that baseline is, whether it is you have something from your historical use of HPS or natural sunlight, we use that as a baseline. The next thing would be understanding the objectives of the grower. What are the objectives? You really want to go after the flavor and taste, or you really want to have increase your production, or you want to cut down the cycle time. Those are the kind of objectives that we get into. So once I have a clear, uh, you know, uh, overview from the grower or the owner, these are the objectives that we would like to achieve. Then we start working on, what would be the different lighting strategies. And yes, the lighting strategies will be different because, say, for example, the basil would need a certain lighting strategy, but along with the lighting strategy, our viewers also need to understand that the environment strategy also changes. So that is important too. So does that answer the question, Henry? Or
Yeah, I mean, I think you're explaining the principle of you need to know what you want to grow. And I think what I'm
exactly.
hearing as well to bounce off of that to contribute from my experience is, you also need to really think about the market. Look at what the market wants to grow, look at what the market wants to deliver. We're talking about leafy greens and herbs here, right? So, are you serving restaurants? Are you serving retail? Are you serving premium retail? What do they want? What are things that are important to them? Because in any controlled environment agriculture, you can adapt the conditions, not just on light, but the total system, of course, to create a more optimal product if you do it right. So the lights are a huge, huge part of that, which Abhay emphasized, but there's other factors as well. But I think it comes down to the market as well, right? What is it, the characteristics that they want that then you can pass on to the suppliers to say, we really want Sollum's lights to deliver on this sort of thing. And I saw that in action, actually. I went to the Chef's Garden, one of your customers. I saw that in
Oh,
person
okay.
action, and there's just one of several projects of yours I visited. There was also another Another one in Canada where they were creating THC strains, and using light for that as well. So the control level is very precise if you have the demand for the specialized product. And I think from my case, in the business side, that's always important. You have to differentiate in the market, and how you can differentiate without control.
Yeah, and that's exactly where, one of the pillars of the solution that I already mentioned with the Sun as a Service software, like as you mentioned, there are different crops, like basil, lettuce, and kale. Each would have a different requirement of, say, for example, the red percentage or the blue percentage for each. So if it was the same greenhouse, as you can see in my background, and I had in one zone or in one bay, I had lettuce, in the second bay, I had kale, and in the third bay, I had basil, I could easily separate those zones and create those three different zones and apply three different lighting strategies to make sure that I'm getting or I'm fulfilling the objectives that I would like for each crop.
Yeah, exactly. So you can really plan your facility around that as well, of course, as it should be. This question is more about the energy, right? So these
Yeah,
dynamic lights are superior, right? They can have more control. So how do they relate in regards to the energy? Do they require more or less energy than a typical LED setup?
yeah, no, and this is again a really pertinent question for this discussion because a lot of nowadays we see increase in the energy pricing, whether it is US or Canada or even in Europe, and it is extremely important because there are certain times of the day where your energy prices are really high, you know, and then there are certain times during the day or the night where you can really use that energy and it is not that expensive. So this is where, to begin with, if it is a hardware, if it's 1,000 watt LED, whether it is a dynamic, our advanced dynamic Sollum fixture or any fixed LED, it's going to be 1,000 watt. Okay, so let's not say that, oh yeah, I can produce the same photons with the 500 watt. No, that's not true. So it's 1,000 watt versus 1,000 watts. So that's the baseline. However, when it comes to the actual application, the setup and how it is run, that's where the differentiation comes in. So just to give an example, we do have sensors whereby we can detect how much natural light you're getting. So say, for example, you are in the Netherlands and you know that during the day, your energy prices are really peaking high and you don't want to run the lights. Or if you want to run the lights, it has to be a certain minimum or the most efficient spectrum that you could run. So what happens is with our AI solution that we have built in our Sun as a Service, with our sensor, they're able to detect how much natural light you're getting. What is the spectrum of the natural light? And this is where it gets really interesting. So you might have a certain light recipe. Say, for example, it is 75% red, 10% blue, 10% green, 10% far, 5% far red. I'm just making up, okay? So if I have that as a spectrum, which is starting with that, and then if I have enough sunlight in the greenhouse, I'm in the Netherlands, I know that during the day my energy prices are peaking up. What the software will do is it will automatically change that spectrum and it will make it more move towards a higher red percentage. So what that does is two things. One is the plants are already getting the what I call as the quota of the blue, green, and the far red from the natural sunlight. So if I was the plant and if I was able to speak, I was like, well, I'm getting enough blue, green, and far red from the sun. I don't need more because I won't be able to use it. So if I have a supplemental light that is moving more towards a higher red percentage, guess what? It's going to do two things. Number one, it's going to help the plant push the photosynthetic activity to the optimum because we know that red wavelength is the driver for the photosynthesis within the plants. So that's what it's going to do. From the grower standpoint or from the owner standpoint, now when you move towards a higher red percentage, you are having energy savings. And this is where the answer to the question comes in. Because if you have a spectrum, say, for example, which has an efficacy of 3.5 micromoles per joule, starting with say 75% red. Now, guess what? When that spectrum moves towards 90% red or 95% red, because I have enough natural light in the greenhouse and I don't need to do anything as a grower, it automatically changes it. I'm going to get anywhere between 20 to 40% of energy savings just because, and you know that because with 90% red and 5% blue or 100% red, your efficacy jumps from 3.5 to 4.0 or 4.2 micromoles per joule. That's where you can get that additional 20 to 40% of energy savings just by moving the spectrum to a higher red percentage. So it's not just energy savings, but now you're also pushing your crop to optimize the photosynthetic activity. So it's like a double whammy in a good way.
Yeah, double win there. We have our first volunteer to talk to us. So Abhishek, are you there? I'm going to ask you to unmute now because you raised your hand to ask a question. And everybody else, if you want to let us know where you're calling in from, that would be helpful as well to contextualize some of these answers in the chat.
So while I think Abhishek is preparing for his question, oh, we
We've got
have
another
someone
one
else.
here.
Yeah.
हमारा आवाज साला वहां जा रहा है भाई
Hello.
Hello, Abhishek. We can hear
ज्वाइन
you.
किया आपका
Okay, you're here. Great. Thank you. What's your question, Abhishek?
Okay. I think there are some technical difficulties, Abhishek, for you. Maybe if you want to just type your question in and I can answer it, that would be fine. But I guess we have another one in the Q&A, Henry, from Ahmed Hashemi.
Great. Let's go with
And
that.
yeah, so what would be the impact of heat and humidity, like in West Africa, on the lighting strategies in general? So that's the question from Ahmed Hashemi in our Q&A. So
Interesting
I'll
question.
definitely, sorry?
It's an interesting question.
Yeah. No, I'll definitely take that. And that is very relevant to when you are doing any of the lighting strategies. So to give an example, okay, because it's a more generalized question with, of course, with the humidity conditions, the lighting, you need to adjust it in two ways. Number one, we need to make sure that the plant is still able to photosynthesize at a certain humidity percentage or the relative humidity that you have. What was the other thing that was asked? Sorry.
Well, it was mostly about like how the light would change for that region and the heat and humidity, right? So I
With
think it's
the heat and humidity, yeah. So
about the
with the
common factors related to the light. Yeah, I mean,
correct. Yeah, so obviously we know that they go hand in hand. Okay, so if I have to increase my light intensity, I also want to make sure that I have enough of the heat or the plant temperature needs to be adjusted accordingly in order that the plant can utilize that additional light. And at the same time, I want to have the certain relative humidity. And that takes me to what we call as the VPD, the vapor pressure deficit. It has to be in a certain range in order to make sure that the plant is actively transpiring, actively photosynthesizing with the light levels. Along with that, we also need the CO2 because let's not forget that, because if you just have the heat and humidity, if your vents are open, your CO2 levels are at 350 or 400, just the ambient. Guess what? The plants are really going for the photosynthetic activity with the light levels, with the temperature and the humidity, and they are like, well, where is my fuel? Where is my CO2? I don't have it. So that can be the limitation. And then all of a sudden you're seeing that despite you have the right temperature, humidity, and the light levels, you're lacking CO2 and your plants are under stress. So to answer the question, yes, all of the like the heat, the humidity, the light, CO2, all of them have to be synchronized. And especially it is challenging in conditions in South Africa where you have, I would say, you are always chasing to control these parameters, and you never are able to control it. Trust me, as a greenhouse grower myself, you are always managing the best you can. Okay, so managing is the right word and not control.
Okay, I'll work on that. Managed environment agriculture. It works. But I think what this question also brings up something we should talk about, right? Because dynamic lights have superior applications in certain conditions more than others, right? So can we actually talk about that a little bit? Because where in the world do you see your lights really being most beneficial? If that's a question that I can ask, because I think we have a global audience here, and they may be thinking about what kinds of facilities make sense with these lights, what kinds of regions, what kinds of climates.
Yeah, so if I had to paint it with a broad brush, I would say any of the controlled environmental agriculture scenarios, you would be able to apply this technology of dynamic LED lighting solutions. Whether it is a greenhouse, whether it is a closed room, without any natural light, you can still would be able to apply this technology. And the reason for that is because that's exactly why it's a fully dynamic solution. And what that means is you can have, say, for example, you can even mimic a sunrise sunset in a closed room. Okay,
I saw
so
that as well. Yeah, I mean, I think even Chef's Garden as well was also practicing some of that mimicking in their
yeah.
work and in a controlled system for sure. I think my question, Abe, more is like, yes, it could have benefits everywhere, but how do you maybe see it in certain regions where you have lower tech greenhouses? I've heard some work being done, for example, with low tunnels integrating precision irrigation and then integrating like CO2 emission strategies with excess. So like the lines between these controlled closed greenhouses, vertical farms, and outdoor farms are kind of blurring a little bit. And when I think about the global south, for example, and the kinds of farms they need, how do you maybe think about that in some regard?
Yeah, so if you're talking about some of the low-tech greenhouses, is that right? If
Yeah,
I'm
I'm curious,
assuming,
like if
yeah.
the fit there, it could be, but mostly, some more research. Yeah, what do you think about that?
Yeah. So no, we do have even in the southern latitudes, like even in North America, whether it is a Florida or California. I just picked those two
Yeah,
states because they do have what we call as enough natural light. Again, from the physiological standpoint, I don't
yeah,
agree to that because yes, you might have enough natural light, but your photo period is not enough during the winter months.
yeah.
And that's exactly where I'm going. So we do have growers in Florida and California who still benefit from the dynamic lighting, whether it is a low cost greenhouse or tunnels. The reason being, as you rightly said, yeah, it's a low cost, but at the same time, they don't have that photo period to make sure that they have enough, hours per day for that particular crop. And that's exactly where if it's a dynamic lighting, the growers would know, well, the plants are needing only far red to have as a day extension. Guess what? You can just run the far red at the minimal cost in terms of energy usage. Now, take that scenario and turn it into the 2 days later, if you're having a cloudy day and your plant is not getting the required even moles per day in terms of DLI, you can switch that same fixture and you can have a more balanced spectrum to provide the crop its particular needs in terms of the different wavelength. So this is how flexible it can be even for the low-tech greenhouses. And if they're running the minimum, as I said, far red or just blue in the morning, they're not going to consume a whole lot of energy just to run those separate channels. And that's exactly where it gets really interesting for the growers, that there is an applicability for each and every scenario.
That's exciting also to think about how much your company has developed already and like what your company could develop to as far as fixtures in the future for a more broad range of dynamic lighting needs across the whole globe. Like that gets my
Yeah,
mind pretty excited about thinking what I've already seen from Sollum Technologies and what could happen in the future. Because I think this idea of combining again, like what nature does and for the plants with what we can deliver through superior engineering, for example, as humans, and strategies based on certain data and science is quite exciting, I think.
Yeah.
At the Vertical Farming Congress here, the emphasis was, of course, like, you have to create a superior product to compete in the market. And I think that's also brings us back to this. So we're not getting some questions from our group here. I think we can go look at our other questions that were brought in again and just take a look here. This one's about going back to the leafy green question, right? Which is the webinar is a bit about. This one's more about, cutting and come again, which I've seen in a few operations myself. A lot of groups do it, not from a lighting perspective, but, for me, yes, you can do this. There's trade-offs, of course, to it. Obviously the plant itself is aging and it's getting more vulnerable to various things, right? So, that's only going to produce as much yield or quality for so long. So I've seen it in certain small situations with leafy greens that work. For example, education groups is a really good application for that. But commercially, it's pretty rare for me unless I see more like a premium product, and that you can create value from a small group of cuttings from it versus the whole thing. That's my experience. What do you think, Abhay?
Yeah, no, you're spot on, Henry, because I haven't seen a whole lot of these applications in commercial, because it comes back to what you rightly said, that yeah, if you keep the same plant over a certain period of time, you start getting some of the issues within the plant, whether it is a physiological issue, whether it is a plant pest or disease issue happening. So those are something that you need to deal with. And also it is more important when it is a commercial growing operation. And what I learned from our customers is they do have like weekly contracts, basically. So they do need to fulfill those contracts regardless of what the weather is. And that's exactly where something like this is probably not a good idea, to make sure that you're staying on top of your contracts and harvesting the same kilos every week. And that's why it is more that we don't see this more often in a lot of the commercial operations. But to answer the questions, yes, absolutely. If you're a home grow operation, if you're growing for, a small, sector, you can definitely get multiple cuts. Does it reduce the yield? Absolutely it does, because it's not, you're not going to keep the same yield every time you have it. And even if you do, it's going to take you a longer time. So say, for example, if it took you 20 days for the first cut, probably the second cut is going to be even 25 days or 27 days in order to get to the same yield, if at all. So absolutely, it's not something that the commercial growers would deploy.
Yeah, I agree with you there. Okay, so Ali Leela is here, would like to ask a question. Let's give that a try.
Hey guys, can you hear me?
Yeah,
Yes.
Hi, there you are.
Perfect. So my question is related more to microgreens specifically. So we grow a very kind of dense grow or dense canopy. Is there a lighting solution or a spectrum that can help sort of penetrate the canopy to get some of the laggard shoots to start to kind of pop up into the canopy? Like how would I try and find a lighting solution that would allow me the dense grows that I'm looking for without having a certain percentage of the crop just not get any kind of light spectrum at all? Trying to solve that problem.
Yeah, no, that's absolutely a nice question, Ali, and thanks for asking it. If I may ask, what kind of microgreens are we talking about? And do you know approximately what height are your microgreens?
Yeah, so I mean, typically the stems, like sunflower microgreens, pea shoots in particular, are the one we're having a challenge with. So we'll get really good germination. We tend to grow them to maybe about a 4-inch stem length or so, but somewhere between 20 and 30% of the stems just never get past like an inch because they get crowded out very quickly from the other ones that have grown aggressively. So we're just trying to figure out how to see if there's a way for a light spectrum to be able to get down into that canopy and push the growth on the rest of those so they kind of catch up or can at least give us the same yield as the more aggressive ones that grow.
Absolutely, absolutely. So There are two things that come to my mind right away with what you are describing. Is if you want the first thing is we know that, and again, this was discussed at the Canadian Greenhouse Conference too. So this is very recent that we heard from even Ep Hewlink, who is the professor at Wageningen University, and he also mentioned that it's something that people say, oh, green is not used at all in the photosynthetic activity, but in your case, Ali, that's the same wavelength green. It can actually have an impact in the canopy within the crop. So if you have a 4-inch crop and you're not able to have certain wavelengths penetrate that canopy, maybe green is something that we have to focus on in order to get that penetration in the canopy. The other thing that I would also advise you to try it out would be also the application of a higher blue percentage. Because what that will do is that will not stretch your crop up to 4 inches and maybe also have a better lateral growth within the crop right from the beginning. And what that would do is it will give a better architecture to your seedlings. And that being said, along with the blue and green, and of course, red would be the driving wavelength for the photosynthesis. But if you would focus on the blue and the green more, I think that's would be a possible solution for your challenge that you're seeing. However, in order to do that, you might need a fixture where you are able to change all the 4 wavelengths or even manage them individually. Because if you have a fixed spectrum, then yeah, it gets challenging because you don't want to keep changing those fixtures as the plant grows.
Okay, perfect. Thank you.
Okay.
Now we're talking. That was a great direct question relevant to this webinar. We're excited to have that. So apparently some of you are having difficulty with the chat. I'm so sorry about that. I don't, but we can use the Q&A feature and I can respond there. So thank you for putting your questions into there. We had a question about tip burn in lettuce. That was one of the ones that was submitted. I'm not going to pull it up here, Abhay, but I was curious, what do you think about that in particular?
Yeah, tip burn, leaf burn is a really common, I would say, challenge for a lot of these leafy greens and lettuce growers. And there are a lot of times, and I'll just make a joke about it, Henry, because a lot of times when I walk into the greenhouse, the growers would say, it's because of those lights. Like as you can see, the lights up top.
Right. I think that's why they're asking the question. This comes up all the time. It's like, oh, tip burn, I've got these powerful lights. Am I going to get tip burn? So
yeah, it's all because of the lights. And I'm like, okay, because it's the most shiny object in the greenhouse, don't just point towards it, but again,
pretty cool.
Yeah, well, jokes apart, there's a plant physiology behind it. Okay, so to give an example, like what you're seeing behind in my screen there, it's exactly a lettuce leafy green greenhouse, and we actually had a similar issue there. Now, when we were looking into the issue, what was happening there, there's a lot of different factors. Lighting, of course, it triggers it even more. Okay, I'm not going to say that, yeah, lighting doesn't do anything. It will trigger it even more. What happens is you need to maintain the correct humidity levels. Okay, that is really important. And at the same time, how much are you consistent with your lighting? So if you have a certain humidity level, if your humidity levels are too high, say for example, and then you blast your plants with a high light intensity, that's not a good scenario to be in. And that's where you can see some of the issues happen. On the other hand, if you have a much better humidity condition, say for example, 65, 70% humidity, you have a much better CO2, and also important if you have an airflow of, say for example, 1 meter per second or 1.2 meters per second, now you have some really good conditions for the plant, and now you can really push with the lighting, and you won't get any of the tip burn, provided if you have all these other parameters that are balanced out to I would say complement the higher light levels that you want to push. So yes, there are a few things that go with tip burn. I want to really bring in some science in here with some of the research that was done at Utah State University. by Dr. Bruce Bugby, and it's a very, a research paper that you can find on Google. He even grew lettuce with under high pressure sodium. And this was a paper that he published without, not with LEDs, but with high pressure sodium, 500 micromoles. That's really high with a high pressure sodium. Imagine the heat that he would get at 500 micromoles from high pressure sodium. However, because he had the correct humidity, the correct airflow, even with 500 micromoles from high pressure sodium, he was able to avoid the tip burn on lettuce. The reason I bring this paper or I like to discuss this paper is just to show that things need to be balanced out and don't just blame the shiniest object in the greenhouse that it is because of the lights.
So, I mean, it goes back to management, and you have to manage the entire system effectively. Do you have any advice, just short advice, right, about like how do you practice that principle and not focus on one factor that you think is going to be the panacea in a good way or a bad way? You know what I mean? But you're focusing on the system overall. Obviously, dynamic lighting lets you play within that system and actually have flexibility you wouldn't get with static lighting. But maybe for some of these growers that are starting off, how do they think about that balance?
Absolutely. And that's where I would put on my grower hat to answer that question. So as a grower, I would know my greenhouse better than no one else.
Yeah.
Okay. So I would know my greenhouse even before I put the lights. I would know what my humidity levels are, what is my airflow, how am I irrigating the crop, what is my CO2 level. So I have all those parameters really dialed in as a grower. Now, when I put the light in, that's the only one factor that now I have to think that is going to drive the crop. And based on that, you can really fine tune. You don't need to make some big changes. You just need to fine tune some of those adjustments. I would say the threshold levels, whether it is for the vents, whether it is for the curtains. And again, being a grower, I would be the best person to know all of these parameters. So I wouldn't walk into any greenhouse and say, you know what, we need to make all these different changes. That would be so stupid.
Okay, great. Let's get into a question here from Dr. Kelly Geloff. If you'd like to speak as well, we can invite you to ask the question directly. Let me just give that a try as a moment, but you can see the question here, Abhay, in the chat. I don't know if you're open to that, Kelly. Let me just give you a chance if you want to. But this one is, we'll answer it here live. I'm curious about how biomimicry and sensors and AI will be influencing CEA in the next decade of research. Which variables do you expect companies will be focusing on dialing in with these technologies? Will we see more soil-based indoor growing versus hydroponics? She wants to hear your prediction, Abhay, about the future.
Wow,
and how can a startup now, think about that a little bit well, maybe it's the second question. Let's start with the first question.
Yeah, so in general, I can definitely answer it. And again, taking you back to my last 2 days at the Canadian Greenhouse Conference, that was one other thing that I saw was a lot of these AI companies, who are coming up with some of the modules, how they would predict the yield or how they can predict the irrigation and the climate, etc. So I think it is in the same, and this is all related to the sensors that would be deployed. So one of the things is, Dr. Kelly, is yes, we are seeing a lot of these companies moving towards having all these sensors deployed, and we are gathering that data. To me, as a plant physiologist, again, it is more important how do we collaborate all of that data and come up with a solution. Because I was talking to one of these companies, I won't give the name, but just yesterday I was talking to one of them and I'm like, I like what you have on your dashboard, but do you know how this temperature is going to impact with a certain light level and what humidity you would need and what would be the irrigation practice at that point? There was no answer to that. And exactly those are the things that we as growers, and again, I'm putting my grower hat on, we as growers, we need to understand that, because otherwise I would have all this data, but if I don't know how to utilize that data and apply it to my greenhouse or to my operation, whether it is even a controlled environment in a closed room. All of that data wouldn't make any sense. You know what I mean, Henry? But
I agree with you. I mean, I think the future, to give a prediction, is I even hope it is and want it to be an AI human future, right? So we think about agronomists in the future. I think about one of the things I've heard about in a non-CEA sector. There's this WhatsApp app in Mawali that's an AI app that's been supported to give agronomy knowledge to farmers, but it's an LLM like a ChatGPT, and it's been quite successful. But one of the reasons why it's successful is because it's on WhatsApp, it's easily accessible. And the second reason is that it has live agronomists that can step in to validate and contribute to the conversations that farmers are having with this LLM. And I think that's what the future looks like to me in the regards to these things. And it's inevitable that the data will be refined and optimized. It's inevitable to some extent there'll be some automation, but there's an increasingly important role for agronomists that can understand how to bring these things together. And that's, for example, what you're doing already, because you have this AI enabled, software solution, and then the agronomists that you can contact any time of day. I got to see some of them at your office. It's really a cool setup that Sollum has for that future, I would say.
Yeah, thank you for that, Henry. So yeah, absolutely,
I mean, it's like
we do try.
You're actually preparing for it, doing it, so it's good. And okay, so we got a couple of questions here. This is what we've gotten in a previous one about lights, but just about like the minimums that customers would think about related to Sollum. We get that one quite a bit, Abhay, on our webinars, and I understand it, right? And they're asking, of course, is the costs for the fixtures versus the service, and that varies. But can you give us an answer on that one?
Sure. Yeah. So to begin with, the minimum number of light fixtures, it's a broad-based question because depending on how much light intensity you want to target, and depending on the area. So going from say 100 micromoles, 120 micromoles to for cannabis growers up to 1500 micromoles or 1800 micromoles, that will definitely change the number of fixtures that you would need per square meter. Okay, if that answers the question, because I cannot say that, yeah, you need one fixture. Depending on your requirement, it will change. And that's something that we offer as a service to the customers. They can send us the dimensions, they can send us the crop, what light levels they're looking for, and we can generate a lighting layout, a lighting map for them, which tells them how many fixtures they would need and what would be the light levels. So that's that part. In terms of the cost, what I would say is over all these years, even with the dynamic spectrum and a fully dynamic fixture, the costs have become much more commercially viable. So if I need to talk in terms of, I wouldn't give a fixture cost per se, because it will differ based on the ppf of each fixture. How many moles or how many micromoles has been generated by the fixture per the wattage used. So it is, for anyone on this call, it would be easier for you to compare the cost in terms of micromoles. So how many dollars does it cost per micromole? And you can compare that for a fixed spectrum LED, for a dynamic spectrum LED. And that's where you can come up whether it is safe. Excuse me, say for example, is if it is a 12 cents a micromole, or if it is 15 cents a micromole, is it 17 cents a micromole? And what is the difference, and why is this difference going from 12 cents to say 17 cents a micromole? Okay, you can even get some of the fixtures if you're buying from a non-reputed company from somewhere across the globe. You can get them for really cheap, but at the same time, you need to know what your objectives are, what you're getting into, and what your output is going to be, the warranty. There are a lot of different things that need to be considered when it comes to the pricing. You cannot just have go to, as I always make fun of growers, if you're just looking for light, just go to Amazon. You will find a lot of different fixtures over there and you can pick and choose. But if you want to look for a solution, that's where Sollum can come in and help you get the correct solution.
Yeah, and I think obviously Sollum is there and would love to speak to any of you looking at that. But I think just as a consultant, because I'm getting some questions here as well from others about business case, and this relates to that a bit. I want to emphasize again, like a lot of these questions are answered by the market. So what does the market want to buy, or what are you going to bring to the market that's new that they're going to want to buy? Okay. And then you design your business around that, right? I think we all have a tendency to go straight to the technology, and that's great. But that sort of relates to your Amazon thing. If it's like, if you just want to buy something, do that. But if you want to do it right, like you have to
Right.
do multiple different steps. So when there's questions about what is the right leafy green to choose, it really depends on your market. Some markets, for example, will pay more for a smaller head of lettuce than a bigger head of lettuce. That's actually something that happens. They will pay more for a baby, or teenager rather, version of it, this bib lettuce that we see sometimes, because they want it in a small contained live product. It's going to go onto a plate and looks cute, it's nice. But if you don't know that, if you don't know that research, designing your system to grow that, right, is not the first step. The first step is who's buying that and how many of them are there, because then you can start to make the business case for the level of control and management that CEA requires to deliver on that. So I think I want to make that really clear, because that's just going to be a very important decision. Now, as far as the question on nutrient profiles, that's a complicated one to some extent. Do you have any thoughts on that one, Abhay? You know, which ones have the
Yeah.
best nutritional value, et cetera?
Yeah, like the leafy greens that have the best flavor profile and best nutritional value. That's a pretty, I would say it depends on
Subjective,
whom you
right?
talk to. Like,
Yeah.
I know, Henry, you might have a different opinion than I do. We
Look,
all
I
do.
think we have to be right. Like, what's the water weight of lettuce? Lettuce is vitamin water. Do you know what I mean? So I think it can provide certain things, but the darker greens can provide more nutritional profile. If you're, look at that, there's certainly brassicas and other products that can have a richer nutrient profile, or solve certain nutritional deficiencies that might exist, maybe around potassium or something else. There's things to look at there, if you make that decision. But again, my emphasis would be who's paying for that, right? Like, who's the person who's paying for that extra benefit? I think there are cases for people paying for certain nutritional qualities, but there's more cases of them paying for taste. So if you look at the most successful leafy green producers, like in North America, right, they are getting consistent reviews from the customers that they want to go back, right, over and over again, and they like that product and they're buying it, and the data suggests they're buying it. That is success in leafy green CEA production. Like, that's what it looks like, is that you have these, you have that consistent demand, you can produce it consistently, and the customers love it. That's more, the nutrition, I think, as well, just to add to this, is driven by freshness, in my opinion, and the overall skill of the grower. So the skill of the grower, this management, all these things they need to do, combines to create that nutritional quality and that flavor. Because if it's grown incorrectly, it's also not going to have, or if the lighting is wrong, nutrition will be affected too, right?
Yeah, and that's exactly where I would just like to add to what you're saying, Henry. Like, say, for example, in Europe, they're very much sensitive about the nitrate content. Say, for example, right? So you want to have a lower nitrate levels in your leafy greens or lettuce. And one of the things I can definitely tell you or tell our audience is if you are looking to reduce the nitrate levels in your final, like before harvest, in any of your lettuce or leafy greens, that is possible by having a certain lighting strategy. So you could actually grow the crop throughout its crop growth period, whether it is 28 days, 34 days, or 60 days even for romaine, depending on what kind you're growing. So you could actually reduce that nitrate content in the leaves or tissue. You can do that by having a certain lighting strategy in the last few days before you harvest. So that's the power of lighting when it comes to. And so one thing is you're doing it with lighting. So there is no other chemical, no other PGR, nothing that you're using. So it is purely natural. No one can, hold you against it. And still you're reducing the nitrates, which is good for humans. So
There you go. That's another example of the power of lighting, and the dynamic lighting that can control that. So one last question here from Virginia, from Lauren Schaefer, talking about broad spectrum systems versus specific programmable spectrum light. I think that's what the whole thing is about here, right? But maybe what would we add for that? I mean, look, what are your options? You can buy like an HPS light. creates heat, hugely energy intensive, being phased out. You can buy a static LED light where you get a certain spectrum, and then you can't change your crop and you can't adapt to issues with climate as far as the lighting is concerned. And then there's some whatever. What else is there? You know, what are
Yeah,
the
so I would really like to answer this with an example.
Yeah.
And I know this is not an example for leafy greens, but it is definitely an example against the broad spectrum lighting and the dynamic spectrum lighting. So the way it works is, and if I understand him correctly, when he's referring to a broad spectrum lighting, it is more looking at like a whiter light, like it's not like the pink,
Yeah, it
the
includes
typical
UV.
pink light. It's like it's a white light that they're referring to. So we have done trials where we have the broad spectrum light, the white light in the greenhouse. It's a tomato crop, right? And in 2 bays, we had the dynamic lighting installed. So all the other conditions for the growth were exactly the same. The temperature, humidity, VPD, airflow, irrigation, crop management, everything was exactly the same. The micromoles are also the same. So the plants were getting the same micromoles. The difference was the rest of the greenhouse was the broad spectrum, as per what the gentleman was saying. And that was all the broad spectrum, except for the 2 bays, which had the dynamic spectrum. And what that means is the spectrum was changing as per the day progressed, as per the stage of the crop. The outcome, we got 19.5% more yield compared to the broad spectrum. The reason I want to emphasize this, that is the power of dynamic lighting spectrum, and the plants do respond. This is the proof that the plants do respond to the dynamic light throughout the day, throughout their crop cycle.
Yeah. Well, thank you so much, Abhay. It was nice to catch up
Oh,
with you.
what? Are we near the end of our time already?
Yeah,
Oh,
I
yeah.
think we are.
Wow, that went quick, Henry.
I mean, I think we got some good questions here, and yeah, let's wrap it up here a little bit. I just wanted to say, are there any other events coming up that people can see you at or meet Sollum at?
We will be at CE Ag in November in the Northeast. We have that event coming up. I wouldn't be there, unfortunately, but my colleague Matt Bonavita, who is the VP of Sales for US, he will be there. So if you are attending that show, CE Ag event in the Northeast in November, please make sure that you meet Matt Bonavita.
Okay, I'm getting this question from Sharandan. I believe, Sharandan, your question was about tip burn, which we did answer earlier. That's the one you put in there. So if you want to ask one more question, if you feel like we haven't answered that, that's great. But we answered the question about tip burn that you submitted. If you'd like to re-put your question in on the Q&A chat. When we tried calling you earlier, it didn't quite work out. So let's just do it there since you're able to do it. And yeah, Dr. Kelly, we will definitely be able to share this event with those that participated. Thank you for those that joined. And just trying to see, Sharandan, you can also send us the email about this, but we did talk about tip burn, which was the question. So I think we will wrap up here instead, Abhay. But CE Ag World happening in November. I agree. We'll see you there. We're actually going to be talking about the CA census there. And what's interesting is there's some optimism from certain groups to expand their facilities. And those are good opportunities to consider, lots of new technologies. So we'll see Sollum there. Thank you for joining our webinar today with Sollum Technologies and Agritecture. You can learn more about Sollum Technologies online at sollumtechnologies.com or on social media or at one of the events coming up. Thank you again, Abhay. Really appreciate your time.
Thank you. Bye.